How's it going, everyone? Cup of Science Joe here. One of, if not the oldest spacecraft still communicating with us, Voyager 1, has been exploring space on our behalf for 47 years. In this time, it has traveled 163 astronomical units, which is 15.2 billion miles, and was the first spacecraft to leave our little party here in the solar system and venture its way out into interstellar space. Even with most of its instruments turned off, it still has the capability to gather scientific data for us, along with sending it back to us here on Earth. Pretty incredible, I would say, for equipment developed in the 70s. Unfortunately, even this ability may have become compromised. Before we get into that, though, let's take a bit of a deeper look at Voyager 1 and its history, along with maybe a bit of its counterpart Voyager 2. The Voyager program, which included both Voyager 1 and 2, was originally going to be part of the Mariner program. Had this been the case, they would have been called Mariner 11 and Mariner 12. But they ended up being moved to another program, which started out with the name Mariner Jupiter-Saturn mission. But this was finalized to the name we know it as, the Voyager program, when it was thought that the design of the two spacecraft had progressed beyond that of the Mariner probes that preceded them, thus earning it the different name. The goal for the Voyager program was to study the outer solar system along with the interstellar space that lies beyond the Sun's heliosphere. To this end, Voyager 1 was launched on September 5, 1977 by NASA. It would go on to make flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. Now, for this last one, there was a choice between a Pluto flyby and the Titan flyby. Titan was chosen because it was known to have a substantial atmosphere and is the only moon in our solar system that has this, making it quite the point of interest. Let's have a look at some of the images of the planets and moons that Voyager 1 took for us. After taking its last image, known as the Solar System Family Portrait in 1990, the cameras were turned off to save power and memory for the instruments that would be useful for its extended mission. After studying the outer solar system for us, Voyager 1 continued its journey farther out into space. On August 25th, 2012, 35 years after it was launched, it crossed the heliopause of the Sun, entering interstellar space. The first, and at the time, only spacecraft we had launched to achieve this. Though its counterpart Voyager 2 would end up achieving this as well 6 or so years later in 2018. Voyager 1 has an impressive suite of science instruments, but over the years, several of them have been shut down to conserve power and extend the mission. Let's go ahead and have a look just at the ones we still have running on it, though. We have the high gain antenna. This is how we communicate with the spacecraft. It sends us what information is still being gathered from the online, lower powered instruments. Magnetometers and the low field magnetometer. These help us measure the magnetic fields of the Sun and the outer planets. In 2015, it discovered for us that even past the heliopause, solar winds can still redirect the magnetic fields of charged particles that they encounter. Speaking of which, we have the low energy charged particle instrument. This measures ions and their distribution in the outer solar system. This is what helped us locate the edge of the heliopause, informing us of when we passed it. We have the hydrazine thrusters. These just help propel the spacecraft, along with keeping it warm. The optical calibration target. This helps calibrate the craft's charged particle instrument. And when they were still running, it did the same for the infrared radiometer and its cameras. And of course, the juice of Voyager 1, the radioisotope thermoelectric generator. This is what powers the spacecraft using plutonium-238, though it will lose its ability to do so by around 2026. Despite this, it has allowed for an extended mission up until this point, I think at this point passing over 30 years. However, as I mentioned earlier, the mission currently has become compromised. In late 2023, Voyager 1 started sending back garbled data. In place of decipherable ones and zeros, it is now sending something akin to a dial tone, with no sensible data to be gathered. A blow to the Voyager team, who is surely sad and frustrated to have the spacecraft still working, but muted. At this point, we are not certain exactly what the cause of the issue is. However, it is believed to be a bit of corrupted memory in the FDS. This is one of the flight data systems that helps the spacecraft's onboard computers relay data back to Earth. Because it is not communicating properly with the telemetry modulation unit subsystem, not only is no data being sent back to Earth, but it is also hindering the ability to troubleshoot and really nail down what the problem is. While I believe the team is working tirelessly for a resolution, this might spell the end for our most distant explorer. This would surely be a sad outcome, but at the same time, I am truly impressed with just how long over its initial mission time it has lasted. Even if it becomes time to retire Voyager 1, it will continue its journey ever farther into space, a mark of just how impressive our ability to explore has grown in a truly short amount of time. Also, the program still lives on strong through its counterpart Voyager 2, whose running systems are still healthy and in order. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.